Hello everyone, welcome to another video of TIS Tech Interview Simplified. And today we'll be talking about web application architecture. So web application architecture consists of either one layer, or we can say one tier, two tier, three tier, or n tier. And here tier can also be referred as a layer. And mostly the three layers which are involved in this architecture pattern, they are presentation layer, business layer, and data layer. So presentation layer is also known as client layer, basically where your app is being presented, which is the topmost layer of an application. And this is the layer where we see when we use the software. So by using this layer, we can access basically the web pages, or if it is a mobile app, the different sections of mobile app. And the main function of this layer is to communicate with the application layer. The layer passes the information which is given by the user in terms of keyboard action, could be mouse clicks, or basically it could be any data passing from presentation layer to application layer. So for example, the login page of Gmail, where an end user could see the text boxes and the buttons to enter the user ID and the password, and then to click the sign in. So uh, this is where presentation layer comes into picture. For application layer, this is also known as business logic layer or the logical layer. So if we can go further in our Gmail example, so once the user clicks on the login button, the application layer interacts with the uh, database layer basically and sends all the required information to the presentation layer, whether the login was successful or not. So there is basically a constant to and fro communication happening among these layers. And when you talk about application layer, uh, so it uh, acts as mediator between the presentation and database layer. And the data layer is, of course, your database where data is stored. And uh, application layer communicates to database, and it communicates to presentation layer both. To data, especially for the data layer, it communicates to retrieve the data. So these are three different layers in the software architecture. Now, if we talk about a single layer architecture, so uh, it is basically, we can say that single layer or single tier architecture is putting all the required data or all the components of a application. When I say all, it means the backend and front end both on just one server. We can say that this is a good way to test your application in development environment. And it is an ideal solution, could be an ideal solution for very small utilities or very small sites, which has very low traffic, where you don't want to increase the cost in terms of infrastructure. And very rarely you can go for a single tier uh, application, because it comes handy to manage and maintain a single tier application, and it becomes cost effective as well. But at the same time, having all the resources on the same machine can create an availability and security risk. For example, the machine where you have all your components is down, that means your application is down. Or if there is some security concerns with that, that means your application is under threat. So, this way it is not very secure, it is not scalable, and the availability concerns are also there. Uh, Now talking about two-tier architecture, or we say client-server architecture also. So here the communication takes place between client and the server through request and response. And in this type of architecture, the presentation layer or the user interface, which is nothing but this client, it could be a browser, it could be a mobile app, can be anything. Uh, so uh, so basically, user interface layer runs on the client side, while data set layer runs on the or gets executed on the server side. There is no business logic layer or intermediate layer in between. And this is what a two-tier architecture is. Uh, so client is basically could be one program, or it will request a service from a server, which is another program. So it is a request response service provided over the internet or through an intranet. And in this model, client will serve or executes a code, which will be a set of action over network. And while server, on the other hand, sends the result to the client system as requested. So in this, like client computer here provides an interface to an end user to request a service or a resource from the server. On the other hand, server then process the request and displays the result to end user. And the application logic and the presentation logic both are written at client level, and the business logic, data logic, and some of the piece of application logic is written at server level. So an example of client server model could be an ATM machine, where a bank is the server for processing the application with large customer databases. An ATM machine is the client having a user interface with some simple application processing. So this is what the two-tier or client server architecture is. Now, if we compare two-tier architecture with three-tier architecture, here what is happening that you are getting an application server or business access layer in between. And basically the function of business layer is to, or the application server is to accept the data from the client that is being passed and pass it to data layer. Business logic, it acts an interface between client layer and data access layer. All business logic like validation of data, calculation, could be insertion or modification are written at this logic layer. It makes communication faster and easier between the clients and data layer, and it defines a proper workflow activity that is necessary to complete the given task. This is the three-tier architecture. And now moving to the n-tier architecture, which has some more boxes as you are seeing here. Whereas the client remains same, the data layer remains same, but in between we can have n layers. So if we talk about in detail the multi-tier architecture also, it is called. If we talk about it, it solves the problem of splitting the data across more than one server. So having all the resources spread into different server boosts your deployment performance. And in addition to this, having different layer for different resources implies adding on extra security by separating data from code. So here, like we are seeing, presentation layer is there. We have a logical layer or business layer where we have business model being processed, and the application logic processing is also happening. We have an integration layer where we have different type of messaging model present, and the data access is also present at integration. The services are being integrated at this layer, and these layers are basically separated by code. And the again, the need of these layers is, if we follow the software design principle, so the single responsibility principle and the separation of concerns are two things which play a very major role in defining the architecture of any system. So when single responsibility principle, it means giving one single responsibility to any one of these entities or component so that it can perform its operation without any issue. When we say issue, it could be like saving data, could be running the application logic. So, or it could be ensuring, the writing to database. It could be anything. So basically the single responsibility is given to one single layer, and this is what single responsibility principle is. And by having this in our application, we can have our components loosely coupled in terms of responsibility, and making any change to any of these layers will not impact any other layer, and it will give us flexibility in deployments and flexibility in enhancing any of these layers. Separation of concerns means almost the same thing, and basically what it means that every layer will only, its operation will only be limited to what it is doing, and it will not be connected in any way what this other layer is doing. So for example, this layer is responsible only for presentation, and the application logic processing is happening at this layer, and they are not related. In between there could be a messaging which could be passing the data, but it would be a third layer, with its single responsibility. So basically the responsibilities are divided in such a way that you keep them separate, you make them reusable, and I mean, this is the way to go. So having loosely coupled components is the right approach to follow, and with this, scalability is also achievable, and and the security risk is also minimized. And these layers that we are talking about, they are basically at your source code level, uh, and these layers are basically the representing the how your code is logically aligned. So it is nothing but code and the way it has been written as part of different components. And these layers are representing how they are physically separated. So when we use all these tiers in one application, uh, it becomes an n-tier architecture. And nowadays, all the web application n-tier can be, uh, as the name suggests, it could be several tiers. And right now, all the modern application are using uh, n-tier architecture, because the primary goal there is uh, availability, consistency, the performance, eliminating the security risk, and not having a single point of failure. Thank you so much for watching this video. We'll continue in our next video. Thank you.